11.6 Surface Areas and Volumes of Spheres. This one looks a little long, but I think we can get through it pretty quickly. Okay, surface area and volume of a sphere is based, of course, on radius. These are just very, very, very special circles. Some new vocabulary for us. A sphere is the set of all points in space that are equidistant from the center. Now, you should recognize this definition as it was a circle, but this time we're in 3 dimensions. Our radius has an endpoint at the center and the other endpoint somewhere on the sphere. So not only does this radius go from the center to here, but this radius can go to here, it can go to here. The radius goes everywhere in 3 dimensions. So it's just like a circle, only now it's in 3 dimensions. Okay? And a diameter is the segment that passes through the center and has endpoints on the sphere. So we know our diameter goes straight across like that. Diameters will also go straight across there, and diameters will also go there. So as long as they go through the center and touch the edges of the sphere, it's a diameter. So just like the diameters we know, you just now have to think in 3 dimensions. Some new ideas here. We have intersected our figures before, but something kind of neat here is that when a plane and a sphere intersect in more than one point, so it has to cut across it, that intersection is always going to be a circle. No matter how this plane cuts this sphere, it's always going to end up being a circle when we are done cutting through it. If it cuts through the center, then it's called a great circle. This is like the equator on a globe. Now there are multiple great circles. You can think of these like as the longitude on a globe, the ones that go up and down. As long as it goes through the center, it can cut through sideways like this, it can cut through sideways like this, front to back, anywhere. As long as it cuts through the center, it's going to be a great circle. Now, the circumference of a great circle is the circumference of the sphere, right? Goes around the middle. This is, like I said, the equator, or any longitude line. And a great circle divides your sphere into 2 hemispheres. That's kind of like our semicircles. Those are the same prefixes there. Hemi and semi are very similar. So some neat vocabulary next time you look at your globe. All right. If we use a baseball to model a sphere and approximate its surface area, you have to make a baseball using flat pieces of leather. So if we unfold our baseball here, basically we end up with 4 circles. They're basically circles, not quite, but they're basically circles. And we know that the area of a circle is pi r squared, right? We could find the area of any one of these circles. And like we did back with our prisms and pyramids, okay, we just take the area of each one and we would just multiply by 4. So our first theorem here uses this basic idea. The surface area of a sphere is 4 times the area of a circle, 4 times pi and our radius. So we have one single equation. Every sphere you run into, the surface area is 4 pi r squared. So of course we need the radius, and off we go. All right, let's look at our example. What is the surface area of the sphere in terms of pi? Well, in this particular sphere, we are given diameter is 10. We know that we need radius, so that will be 5 meters. We plug it into our formula. Be sure to square your 5. We get 100 pi meters squared is the surface area of our sphere. Go ahead and pause the video and do the next example. Okay, we were asked to find the surface area of a sphere given a diameter of 14 inches. We know that we need radius. Divide that by 2 is 7 inches. We write our formula for the surface area of a sphere is 4 pi r squared. We plug in our numbers and we get the surface area of our sphere is 196 pi inches squared in terms of pi. And if we throw that into our calculator, we can round to the nearest tenth, which is 615.8 inches squared. The problem asked us to the nearest square inch, which would be 616, because it wants us to round to a whole number. But you know I'm fond of to the nearest tenth. All right, that was pretty easy. Let's look at what's next. We're given the Earth's equator is about 24,902 miles long. So the equator, we know the equator is a circumference. Circumference. Okay? We want to know what the surface area of the Earth is. Well, we know that circumference is 2 pi r. We know that anything we need to do with circles or spheres or the like has to have a radius. So if we write our formula for circumference, we can substitute in the circumference. We divide both sides by 2 pi, and we can have r. Now we can use a calculator to get a decimal, but this is going to be, a really long decimal, and we like to round at the end. So we could put in for our r squared, we could put in parentheses 24902 divided by 2 pi, and then we could simply square that. Make sure you use your parentheses so that our calculator would get that irrational number correct. All right. Pause the video. Do the next example. Okay, we were asked for the surface area of a melon with a circumference of 18 inches. So we write our formula for circumference, substitute in. We divide both sides by 2 pi. Remember, pi is just a number, acts like any other number. And so we reduce and we get the radius is 9 over pi. We go to our surface area formula, substitute that in for radius. Do not forget your parentheses. These parentheses right here, your calculator does order of operations. So if you're going to put in the calculator, make sure the whole thing, make sure that you put that in parentheses. And it's going to come out to be 103.13 inches squared. We were asked to do to the nearest 10 square inches. So our 3 rounds down, so approximately, we should put that as approximately, because it's not equal to 100 inches squared. All right, pretty easy. Oh, this is neat. Now, we want to find the volume of a sphere. Well, if we look at our sphere and we break it down into these pyramids, we know how to find the volume of a pyramid. We know that the volume of a pyramid is 1/3 times the area of the base times the height. Well, our height is just going to be a radius. It goes from the center out to the edge. So we can substitute in height for the radius. And so then it's 1/3 times the area of the base of this pyramid, which isn't really a square. It's kind of curvy. So that's going to cause us a little bit of problems. and then times the radius. And then however many pyramids we have, so that's our n is the number of pyramids, we would just multiply the volume of one pyramid times however many we broke it up into. Okay, now the number of pyramids times the area of the base. Well, how do we get that? Well, let's think about what is the area of one of these bases. It's just some area on the surface of this sphere. And what is all of these bases? Well, that is simply the surface area of a sphere. And we know how to find the surface area of a sphere. So we can substitute in 4 pi r squared for these bases, the area of all these bases. So we get 1/3 times the surface area, 4 pi r squared, times one of these radii, a radius, okay, which is the height of one of these pyramids. So we put all that together and we get 4/3 pi r cubed, which incidentally is our next theorem. The volume of a sphere is 4/3 times pi times the cube of the radius. So we have a formula here for the volume of a sphere is 4/3 pi r cubed. This is every sphere you will ever run into. And if you notice, all we need to know is the radius. So let's look at our example here. We want to know the volume of the sphere in terms of pi. Well, what do we know? We know the radius is 6 meters. We write our formula, 4/3 pi r cubed. We substitute in radius. Make sure you cube that 6 on your calculator. 6 cubed looks like 6 raised to the up hat raised to the 3rd power. Okay, 6 up hat 3. This will give us 288 pi meters cubed. We could throw that into our calculator if we want a decimal. Go ahead and do the next example. Pause the video and do the problem. All right, this was a pretty easy problem. We're told it has a diameter of 60, so we know the radius is 30. We write our equation for the volume of a sphere, 4/3 pi r cubed. We plug in our numbers. Don't forget to cube your 30. We get 36,000 pi inches cubed. We can turn that into a decimal, and we are asked for the nearest cubic inch. So that's a whole number, so that's just 113,097 inches cubed. And the next question is another one of our questions on halving our radius. Now, the radius in the volume equation is cubed. So if we're going to half it, we have to cube our 1/2. And if you remember your exponent rules from algebra, both of those numbers get cubed. So it's going to be 1/8. If we make our radius 1/2, then our sphere, the volume of our sphere is going to be 1/8 of that. So that's pretty interesting. All right. So it says you only need to know the radius of a sphere to find volume and surface area. That means if you know either one of these, you can find the other one. So we did circumference before and found the radius and used that to find surface area. So now we are given the volume is 5,000 cubic meters and we want surface area. Well, we know our formula for volume. We substitute in, and to get rid of a fraction, right, we multiply by the reciprocal, gets rid of our fraction, and then we're going to divide by pi, so that's where we get our 3/4 pi on this side. And this is r cubed. Now to get rid of a square, we took the square root. To get rid of a cube, we take the cube root. Now on your calculator, moving things around here, cube root is the same as an exponent of 1/3. So on your calculator, that looks like your number raised to the power, up hat, and you need to make sure that you use these parentheses here because your calculator knows what's going on. You want to make sure your calculator knows that you're doing 1 divided by 3. So this is our number raised to the power of 1/3. You can also use the math button, and you see on number 4, when you push your math button, you will see cube root. So you can do either one of these. This deserves some big red stars. Flashing neon highlighter if you have it. So you can either up hat to the 1/3, make sure you use parentheses, or you can use the math button and use the cube root. Make sure you use parentheses in there as well. Calculator likes to do things proper order. All right, so then we have our radius. Now you can turn your radius into some big long decimal, but we don't have to do that. We can keep it as a cube root of 5,000 times 3 over 4 pi to the 1/3 power and put it all in our calculator at once. But what we have to do is square that because our radius is squared. Now, if you remember your exponent rules, you know that a power to a power multiplies. So if I have something raised to the 1/3 power and then I square that, okay, power to a power, I'm going to end up with my number raised to the 2/3 power, because 2 over 1, this is 1 over 3 times 2 over 1 gives us raised to the 2/3 power. So on our calculator, that would just be our number up hat parentheses 2 divided by 3. There's a number of ways you can do that. Find one that works for you. All right. Ooh, this is our last problem here. Pause the video and try the last problem. All right, this problem took a little bit of being careful with your numbers. We were told the volume is 4,200 cubic feet, so we write our formula for volume of a sphere, 4/3 pi r cubed. We substitute in our 4,200. We multiply by 3 over 4 to get rid of our 4/3. We divide both sides by pi, and we end up with 3 times 4,200 over 4 pi. Now I just put that in my calculator and reduced it down to 3150 over pi. So that's r cubed. Now remember that you need to cube root that. It's not a square, it's a cube. The opposite of cube is cube root. So we cube root both sides, and we end up with r is the cube root of 3,150 over pi. Don't forget your parentheses. You can write it as an exponent of 1/3, or you can leave it with the cube root symbol. Then I take that over to my surface area formula, which is 4 pi r squared for a sphere, and I can either put it in as my exponent of 1/3 and then square it, or I can put it in as my cube root and square it. If you're going to put it in as a cube root in your calculator, make sure you use those internal parentheses as well. Your calculator follows order of operations, and you're going to have to be careful. This is the math button here. This is simply exponents. And we remember that our exponents, a power to a power, multiplies. So in my calculator, I'm going to put 4 times pi times, I'm going to use parentheses, 3150 divided by pi, and then I'm going to up hat and use parentheses 2 over 3. Either way, you will get exactly the same answer, the surface area of 1,258.9 feet squared. This time it did ask us for the nearest tenth. So, surface area and volume of spheres are really pretty straightforward. Simple equation, substitute in your radius, and off you go. Now you can, anything about circles uses the radius, circumference, area, surface area, volume. So if you know one, you can solve for the radius and find any other value for spheres. Just be careful, keep track of all of your steps, write them out nice and big, don't squish things in, and you'll do fine on these.